Jumping more into the RUNX1 gene itself, thinking about, well, what does it mean to have a mutation in that gene? Why do we care about it? So the RUNX1 gene is what's called a transcription factor. So it binds to other genes and helps turn them on and off. So you can kind of think of RUNX1 as a light switch in some ways. It turns on other genes and then it can turn them off, making sure that they're working properly in the different cells of our body. It also plays a large role in embryonic development, but most importantly, it plays a role in the development of hematopoietic stem cells. So hematopoietic stem cells are the early blood cells that have the potential to develop into all types of mature blood cells. So thinking about the white blood cells, the red blood cells, and platelets. We really need RUNX1 to be working effectively to have a healthy blood system. When people have mutations in the RUNX1 gene, they're said to have an autosomal dominant genetic condition called RUNX1 familial platelet disorder, or RUNX1 FPD. People with RUNX1 FPD have increased risks to develop low platelets or thrombocytopenia. They can have a normal number of platelets, and those platelets might not be functioning appropriately. People with low platelets or platelets that aren't functioning appropriately can have things like easy bruising or bleeding. So maybe they bleed when they brush their gums or have bruises all over their bodies and they often don't know where they come from. And then we can also see an increased risk for cancers of the blood or hematologic malignancies. The lifetime risk for someone with a mutation in this gene is thought to be around 35 to 50%. And that's just coming from different literature, different studies that have been done looking at people with mutations in this gene and how often they tend to develop blood cancers. The most common cancers of the blood that we see are myelodysplastic syndrome, or MDS, and acute myeloid leukemia. But we can also sometimes see people developing acute lymphoblastic leukemia, lymphomas, or chronic myelomonocytic leukemia, among others. As you notice on the first bullet point, I bolded the word risks because this is not a guarantee. It's an increased chance or risk factor to develop cancer, but not everyone with mutations in this gene will develop it. And the average age at diagnosis is around 33 years old. That's significantly younger than we would expect. If someone didn't have a mutation in this gene and developed leukemia, we might expect cancer in the 60s, but this significantly decreases the average age of leukemia onset.